So what do we want to think about lines? It's one of the first things we learn, and I want to pose it with the question, of a geometric question in terms of what information defines a line. It's a very good way to approach geometric problems, especially as they get more complex with lines and circles. It's kind of like, well, what is my goal? If I need to find an equation of a line, what information do I need? What's the minimal amount of information I can have to define a line? Any ideas? Anyone got an answer for that? So hard to predict.
One number.
Slope, y-intercept.
We say, so we said an x and a y-intercept, one number. X and a y-intercept's pretty good.
Y equals mx plus b.
2 points.
Mx plus b. We'll get to mx plus b. A little more complicated. 2 points is what I heard. 2 points is generally the first place we want to start. It's kind of the first order answer that most students give. And the question really specifically is like, what type of geometric information, what data do we need to be given in order to find an equation of a line? 2 points will work, and hopefully you guys learned that way back in geometry, sometime in high school, and you learned that any 2 points determine one unique line in planar geometry. I also want to give an alternative set of information. Namely, we can have 1 point and a direction. It's going to be a little bit better way of kind of thinking about the information that we have in lines, and it actually serves as a good purpose in calculus. In calculus, you'll start to learn if I have a curve, then what direction am I traveling at that point? You want to find things like tangent lines to a curve. And so you're given a point, you need to determine the direction. What direction should I walk, right? If I'm given any point in space and told a specific direction to walk, and if I don't change direction and walk only in that direction, either forward or backward, we're going to get a line. And of course, 2 points, everyone's kind of seen it. Any 2 points, we can draw a line between them. Okay, so how do we use this information? Specifically, what do I mean by a point and a direction? Well, a point everyone knows. It's our coordinate pairs, x, y, equals, let's say, 3, 4. What do I mean by direction? Direction, for pre-calc and for Calc 1 and into Calc 2, when we say direction, we really mean slope. It's how we measure a direction. That's really what slope is. I think most people think rise over run, change in y over change in x. But if we're in 2 dimensions, it's telling me which direction I should travel. And we can do that because I'm simply relating how far I should travel up versus how far I should travel horizontally. And so what is our slope? Our slope, as I just mentioned, it's our change in y. So this delta, triangle, we count as a delta, read as a delta, which means change as a Greek letter, which we can determine if I'm given 2 points, we'll write it as y2 minus y1 over x2 minus x1. For any 2 points, I'm going to call them x1, y1. X2, y2 on a line. So this is how we can go, if I'm given 2 points, I can actually reduce myself to this other set of information. These two sets of information are in many ways equivalent, that I can find my direction that I need to travel to get to 2 points simply by using the slope formula. How do we write down our equations of a line, or our formulas for a line? Well, calculating slope is going to be important for most situations. The best form of line, or at least the form that I find as most useful, is going to be point slope form. Which has the form y minus y1 equals the slope times x minus x1. And I guess I should write that somewhere. Our slope, we often denote by the letter m when we're working with lines. Of course, we can use any letter. M is just a common letter. So for example, we had one point above. If I give you the point 3,4 and now tell you the slope, that is all the information we need to define the line. We can write down the equation of the line just by plugging in the numbers into this formula. So our equation of a line is going to be y minus 4 is equal to negative 1/2 x minus 3. And this is a perfectly fine equation. It's nice because it's quick, right? I can write it down immediately as soon as I have a point in a line. It's not nice in the sense that, well, I could give you a different point and a different line. So I could, I could use a different point, excuse me, and get the same line. So for example, if I give you a different set of information with the, let's say we have the same slope, minus 1/2, but I give you the point, what is it? So let's say 5,3. And now we have this other equation, y minus 3 equals negative 1/2, x minus 5. And so the problem with point slope form is, well, how do I know when two lines are the same or not? Did I write down the same equation that just looks a little different? And can we determine that? And the way we determine that is essentially by solving for y. This arrives us at our slope-intercept form. Our problem with point slope form is just that we can use any point. There's almost too many points we can use for the same line. It's useful to write down quick information and get quick answers, but if we want a uniqueness or maybe a nicer looking equation, we maybe want to turn things into a slope-intercept form. So slope-intercept form, hopefully everyone knows and loves. I've heard someone say it in the opening question, y equals mx plus b, where of course m is our slope and our point is 0b. Slope-intercept form is really the same as point slope form. It's just that, what did we do? We took our point was 0, and that's a b, and then I just added that over, and we arrive at this guy. And of course, b, we call our intercept because if x coordinate is 0, that means we are on the y-axis, so b is our y-intercept. In our examples now, so we can always convert any point slope form into slope-intercept form by just solving for y. That's all we got to do. So let's expand out the right. We'll have negative 1/2 x plus 3/2, and then I have to add 4 over and combine those constants. So minus 1/2 x. 4 is 8/2 plus 3 gives me 11/2. If we were to try that with our other equation, y minus 3 equals negative 1/2 x minus 5. We again, distribute our -1/2. We'll get a positive 5/2 and then a +3. 3 is 6/2. And again, 6 and 5 will give me 11/2. And so this is the nice thing about slope-intercept form. If two equations are in slope-intercept form, if they're different lines. If they're the same, they're the same lines. The only way we can have the same line in a slope-intercept form is if the equations are the same. Whereas point-slope form, I can have multiple different looking equations that really dictate the same line, depending on the point we choose. Okay, so let me find, sorry, we need to keep a clock up so we can keep track of time. So it looks like we got a couple minutes before we want to get started on the quiz. So we can do examples. One thing we do want to be careful of is, so let's do one example, or a few examples actually, of just what happens if I give 2 points. -1, 21, and let's say we've got 1, 4, and 1, 7. And then our last one, let's do 1, 4 again, and 9, 4. So when we have a point and a line, or excuse me, a point and a direction, we can write down our equations of a line. This is the form we want it to be in. But of course, we mentioned that if I have 2 points, this is equivalent. But it requires one mathematical step in order to write down an equation, namely, we have to find the slope. So if we want to find a line, so I wrote all these pairs of points, we want to find the line between all 3 sets. Our first step with any of them is going to be to find the slope. So our change in y over change in x in the first case will be 21 minus 9 divided by -1 minus 5. Be sure to make sure you're keeping those in the same order as the numerator and denominator. So for example, my y values, I picked this y value to start with. So I have to do 21 minus 9. That means in the denominator, I have to do that x value minus that x value. You can flip them as long as you flip both. So I could do 9 minus 21, but then I have to do 5 minus -1 in the denominator. If you flip one of the orders but not the other, you'll end up getting a minus sign error. Not a big error, but it is a common error, so just watch out for it. We'll get 12 over -6. Excuse me. So -2 as our slope. And now once we have a slope, I have more information than I need. I have 2 points to choose. We only need one, and it doesn't matter which one we chose. So let's just pick, let's say 5, 9. And our equation of a line is this. Plugging everything into point slope form. And if we wanted to solve it for y, we can get slope-intercept form. Things to be careful of are what's going to happen whenever one of the coordinates is the same. So for example, in B, if we tried to do our slope, what do we get? So UND means undefined. We cannot divide by 0. And what's going on here? This is a special case of a line where normally we can solve for y. The only time we can't are vertical lines. This line, the x-coordinate doesn't change. My y-coordinate can change up and down. So the equation of this line in this case, since x is a constant, x is 1, that becomes our equation. Similarly for the other one. In this case, at least, we can solve for the slope. 4 minus 4 over 9 minus 1 is 0. You can write 0 over 8 or 0. Of course, is what it will reduce to. And 0 slope, it works. We can write it down as an equation. We will have y minus 4 equals 0, x minus 1. And of course, when I distribute the 0, all the x's are going to go away. And we will get y equals 4. And that is our equation of a line. In this case, what's happening geometrically is my y value is constant. Y value is always 4. So that dictates, that becomes the equation of our line. Y equals 4. X then varies. X can be anything. So it doesn't appear as a constraint. It's not constrained by our equation. Any questions on any of that? Okay, so let me go ahead and stop.